Hello friends, today's topic of discussion is surveying measurement and the errors. So we are starting with units of measurement. The unit of measurement is basically uses meter. So if we see the conversion of meters into other units, so 1 meter is equal to 1000 mm. 1 meter if converted into centimeter is 100 centimeter. Talking about inch, 1 inch is equal to 2.54 mm. 1 foot is converted into centimeter is 30.48 centimeter. If we see yard, so 1 yard is equal to 0.9144 meter. Talking about the acre, which we generally use, so acre, if we see, the acre is 43560 feet square, or we can say square foot. And last is hectare, the bigger term. So 1 hectare is equal to 2.471 acres. So as we can see, the major unit is your hectare. Then comes acre. After that, yard, foot, inch, centimeter, meter, and mm. So basically, when we use surveying, the large areas are calculated in hectares or acres. The small areas are calculated in meter, centimeter, or even mm. The next is chain. Now, basically for surveying, we use chain and tape. Now, what is a chain? Chain is nothing but an instrument used to calculate the linear measurement or the length. Now, chain is divided into different parts. We'll be seeing in different videos. Okay. Next is link. Link is basically nothing but the unit of length equal to 1 by 100 chains. It means what? A chain is made up of 100 links. Moving on to next part, the standard surveying terms, the terms, basic terms we use in surveying. The very first term is backsighting. Now there are two sides, foresight and backside. Simply I will give you one example. We are doing a survey and proceeding from point A to B. Whenever we proceed from A to B or measure a distance or angle from A to B, it is known as your foresight. And opposite of it, if we are calculating a distance from B to A, it is known as backsighting. So foresighting and backsighting. The next term is your baseline. Whenever we are starting with the survey, we establish main survey stations. For example, point A, B, C, and D. The line which run across your survey or your field, the main line is known as your baseline, from which we'll be taking out measurements of any required stations, substations, or any required point. So it forms a backbone of, or the backbone of your skeleton, or the backbone of your plot. So it is a main line. It is also known as control line. So baseline is very important in surveying. Moving on to next slide. Next is bearing. Now, what is bearing? There is a difference between angle and bearing. For simple example, now you can say this is angle. Theta is the angle ABC. Is the horizontal angle ABC. Now I have to calculate bearing AB. Now what is bearing AB? Bearing is nothing but the angle which is calculated with respect to north direction. So the point A and this is point B. So if we are calculating angle with respect to north line, then it is known as the bearing of line AB, and bearing is further divided into two parts, forebearing and backbearing. So in the progress of the line, whenever the angle is measured, bearing is measured in the progress of the line, it is known as forebearing. For example, AB. And if we are measuring the angle or the bearing BA, then it is known as backbearing. So bearing is nothing but horizontal angle measured with respect to north direction in clockwise direction, and which is divided into forebearing and backbearing. Moving on to next point, which is benchmark. A benchmark is basically a reference point with which we'll find out the elevations of different points in the particular survey. So there are different types of benchmark we'll see in further videos. Okay, and the next is landmark. Landmark is nothing but a permanent object on a ground with respect to which we'll establish benchmarks and find out the elevation and RLs of different points. Next line is tie line. As we see baseline, tie line is nothing but a bus line but which joins the points of secondary stations. As we can see, these are the boundaries. These are your main points A, B, C, D. A line joining AC or the main line, the control line, is known as your baseline. And the further lines which are joining the substations or secondary stations are known as your tie lines. Okay. Moving on to the next part, now which are surveying measurements. Surveying measurements are of two types, linear measurements and angular measurements. So by using the linear as well as angular measurements, we can find out the relative position of any point on the surface of the earth. It can be used by GPS, Geographical Information System, GIS, and Land Information System for forming a map or a plane. The next point of discussion is what are the errors and what are the sources of error. While measuring linear or angular measurement, there are certain errors. The first error is your personal error. Now, what is personal error? Personal error are caused by the physical limitations of the human sense of sighting and touch. It means while sighting, if we have bisected a different object or we have bisected a wrong object, obviously the reading will be different and error will occur. Same for the touch. If we have to fix lower screw and by mistakenly we have fixed another screw, so there will be an error in calculation. As we can give one simple example, while measuring a value of horizontal angle, we have taken a pole AB, but B, the actual position of B was B dash. We have to bisect a ranging rod at B dash, but by mistakenly we have bisected the ranging rod at B. Or in some cases what happened, the pole, the ranging rod is not perfectly vertical with your plumb bob line. So while bisecting a ranging rod which was already inclined, so we'll get a different readings or the different angles. So this come under personal errors. The next, moving on to second part, is instrumental error. Now your instrument is of imperfectness, like the design or the construction and the adjustment of your instrument is not perfect. For example, imperfect linear or angular scales. As we can see, the scale or the tape is divided into linear measurements. If this linear measurement are not proper or not equally distributed, then there will be a error, which is known as instrumental error. Then instrument axes are not perfectly parallel or perpendicular. Simple example, the horizontal axis and vertical axis should be perpendicular to each other. But while designing or construction of instrument, these are not kept properly perpendicular. then there will be a error if we calculate angle or linear measurement by using such type of faulty instrument. And next is various part of instruments are not aligned properly, like your plumb bob or your bubble tube. Bubble tube should be parallel to the ground. The axis of bubble tube should be parallel to your horizontal line or to your ground. If it is not designed accordingly and the instrument is not calibrated properly, then there will be an instrumental error while taking the readings. And last is your natural error. Now you are perfect, your instrument is perfect, but while taking on reading on side, if there is any physical conditions like atmospheric pressure is more, temperature is more, humidity, gravity, wind and atmospheric refraction, because of this factor there will be a difficulty in taking readings, or we have to take a wrong reading. For example, simple example, a steel tape whose length varies with change in temperature. If it is below the temperature, then it will get shrink. If the temperature is more, it will get expand. So accordingly, your readings may vary. Okay. Then some sunspot activity, its impact on the GPS or while taking or sighting a particular object because of refraction or reflection from the glass, you can't sight it properly, or you may sight a different object, then there will be a error. So these are all errors come under your natural errors. There are three types of error: personal error, instrumental error and natural error. Now moving on to the further part, which are types of error. Now these are the sources of error. Now what are the types of error and their correction? I will correct them. So basically there are two main types of error as compared to linear measurements, which is positive error and negative error. Now what is positive error? My chain is of 20 meter, okay, but while chaining I find it the same distance, I found out 22 meter. Now why it is happened? Because my chain is got shrink, or the links or the rings to connect the chain get bent. Because of that, the original size of the chain get reduced, and when we use this faulty chain and calculated the distance, a known distance of 20 meter, we found it as 22 meter. So we have calculated extra length, which is actually 20 meters. So there was a 2 meter error, and it is known as positive error. As the chain was shrink, the size of chain get reduced and the linear measurement get extra. That is known as positive error. We are calculating more length. This is known as positive error. Now what is negative error? While calculating 20 meter, we actually find it 19.8 meter. Now what happened in this case? The chain was same, but because of excessive use, continuous pulling, the chain get expanded, or when it was used, the temperature was high before it get calibrated. So the expansion of chain take place, or some rings as get expanded or bent, or links get flattened, because of which the actual size of the chain get increased. So we have to measure 20 meter, but it is find out only 19.8 meter. This meant what? There is a negative error. So actual length is 20, but we get 19.8 only. That is known as negative error. So here is 0.2 meter negative error. So you understand, if the length measure is more, that is known as positive error. If length measured is less, it is known as negative error. It is caused because of some natural errors or personal error or instrumental error. The sources of error is any of this above. We'll see the numerical based on it in further part. Now we'll see what are the obstacles to the chaining, okay, and ranging. Now obstacle is can be sometimes a chairman is not able to calculate the distance by using chain, or sometimes the error may be in ranging. We can't range the object in the other side properly because of some obstacles. So there are two types of obstacle, either because of chaining or because of ranging, or because of chaining and ranging as well. Now we can see the first part, which is obstacle to ranging but not chaining. So here you understand. Ranging means what? Ranging means bisecting. So we can bisect the object, but we cannot chain it. The obstacle for ranging but not chaining. This means what? We cannot range it from A. We can't see the ranging rod at B, but we can measure the distance. So we'll take a simple example of this type of surveying. So how it will form? Suppose there is a point A and point B. So there are two ranging rods A and B, which is separated by a hill or an elevated portion, because of which we can do the ranging, but we can chain it by using indirect method of chaining. So what we have to do? Simply we can establish a line AB, or say line PQ on ground. Then from P will pass one line, from Q will pass one line which will bisect the line drawn from P at 90 degree. Means what? We have to drop a perpendicular point from a line drawn on P at point Q dash, where the Q is visible, so that we are eliminating this obstacle by chaining. And now simply we can calculate the distance PQ dash, as there is no obstacle, and we can easily calculate the distance QQ dash as well. Now by using simple formula of your trigonometry, we can find out the distance PQ is equal to under root PQ dash square plus QQ dash square, the formula of hypotenuse. What we have done? We have established 2 points PQ which are actually on ground, and we have to measure it, which is not possible as we can do the ranging. Then we establish a line drawn from P at Q dash, from where we can visible the point Q. We have plot one perpendicular offset. Then we calculate PQ dash and QQ dash, and by using a simple formula we have find out the distance PQ. Moving on to the next case, where the obstacle to chaining but not ranging. So here we can see the object. Objects are visible to each other. We can range it, but we cannot chain it. So which type of obstacle it is, or obstacle it is? There are two types of obstacle in it. The first type is pond or water body. A small water body is present in a particular area. For example, I will take a pond. Okay. Now you are standing at point A, and we have to calculate the distance between A and B. Now what we will do? Simply what we can do? We can see these objects, but we can't chain it. So I will draw a perpendicular from point A and name it as C. This is a perpendicular object to the width of your obstacle, to overcome the width of your obstacle. Then from B, I will draw another perpendicular offset. Now draw a line C which is parallel to your line AB and intersect the object drawn from B at point D. So line CD is exactly equal and parallel to line AB. So simply we can calculate the distance of CD, which is equal to your line AB. The next method is, if suppose there is a river crossing, and now we have to calculate the points. So we'll take a river. Now there are 2 points, suppose point P and point Q, and we have to measure the distance between P, Q. What we can do, we'll draw a perpendicular line from P, a line PA, and we'll find out its center, midpoint, say B. From A, we'll establish a perpendicular at C so that Q, B and C are in a straight line. So from A we have to draw one perpendicular offset, and from B we have to see Q and C are in line. So here we can establish point C. By using this two triangles, triangle QPB and triangle ABC are your similar triangles. By using the rule of similarity, we can easily find out the distance AC is equal to distance QP. So we'll calculate AC, and AC will be equal to your QP. So width of river can be find out by using this formula. Or for second method, we can use this. Suppose there is a pond. For pond I am telling you. Second method, if the linear measurement is not available, then what we can do, from P we'll draw a line at known angle, and from Q also we'll draw a line of known angle. Both lines will intersect at a point we give name as a O. By using trigonometry, we can easily find out your PQ distances, as we can know OP and we can also find out OQ. We can simply find out PQ by using hypotenuse formula or by using your simple trigonometry. So we have to basically use a simple logic to overcome these obstacles. Now the third part, the last part, is obstacle to both chaining as well as ranging. Now what is the example of such type of obstacle? Is a building or an object in the center. Let's consider it as a building. There is a building between 2 points. Let your point A and point B, which we have to actually range and chain. Now what you will do? We will establish intermediate points. So I am establishing one intermediate point C and other D. From A, draw a perpendicular. Same from C, also draw a perpendicular. Join these 2 points at same distance. For example, 5 meters. So from A, this point E is at 5 meter, and from C, point F is at 5 meter. Now what we have to do? We have to extend this line horizontally. From D, simply draw a perpendicular on well established line, and from B also draw a perpendicular. It will represent the points G and H. So what we have done? We have drawn a perpendicular from A as well as C at known distance. Then these 2 points we have extended behind your obstacle. From that points, well established points D and B, we have drawn again a perpendicular to intersect this line at G and H. Now we can easily find out the distance between F and G and also between E and H. So likewise, we can overcome any type of obstacle by using simple trigonometry and simple tricks of offsets and angular measurements. Thank you.